A radio station wants to estimate the mean number of listeners to its most popular radio program. How large a sample must be drawn to be 99% confident the sample mean is within 4,000 listeners of the true population mean? Assume the number of listeners is normally distributed with a population standard deviation of 8,000 listeners. So, like any statistics question, this involves careful reading. What are they asking us for? How large a sample must be drawn? When we're asked to find a sample size, then we're going to be looking for the n. So let's go to our formula sheet and see what we can find for the formula for n. So here we have confidence intervals, and we're looking for a formula for n that we could use in order to determine sample size. And here we have it. Sample size for estimating means n is equal to ZC sigma over E quantity squared. So let's copy that down and see if we can apply it to our problem. N equals ZC sigma over E quantity squared all to the second power. So we'll need to know some things here. We'll need a confidence level, we'll need to know the population standard deviation, and we'll also need an error, so we'll have to be given error in this problem. So let's give it another read. How large a sample must be drawn to be 99% confident? So we're looking for Z.99 then. To be 99% confident, the sample mean is within 4,000 listeners of the true population mean. Now, within 4,000 listeners, that's not the standard deviation there. In fact, the standard deviation is not given to the next line. The 4,000 listeners, whenever they say within a certain amount, that's going to, more times than not, refer to the E, the error in the problem. So our denominator error is going to be 4,000. And the standard deviation, as we said, is given in the next sentence. Assume the number of listeners is normally distributed, which we need for our value of Z here, with a population standard deviation, here we go, we got it, of 8,000. Plug this into the formula, slap some parentheses around it, and square. Now, might as well cross these off because the arithmetic's easy. 4,000 goes into 8,000 twice. Let's just work out Z.99 on our Z table. So let's use the shortcut method by scrolling all the way down. If our confidence level is 0.99, then our critical value ZC is 2.58. So if we plug in 2.58, multiply it by 2, keep it in parentheses and square it, then on our calculator, make sure we follow the order of operations and do inside the parentheses first 2.58 times 2, and then square it. If I enter that in, I get approximately 26.6. Now, an important thing to remember here is that whenever you're looking for n, the sample size, and you want a certain confidence, like 99%, whenever you round, you always round up, so you don't get less confidence than you actually want. So in this case, we're going to round up. Sometimes they put a little up arrow to mean you're rounding up to n equals 27. What I mean is, suppose you get the same or a similar type problem on your final. If it's 26.1, you'd still round up to 27. So always round up whenever we're looking for the sample size n to get a particular confidence.